Okay. Welcome, everybody. My name's Jennifer Griffith, and I work at NUMOA. We'll talk quickly in a minute about what NUMOA is. And I'm joined today by my colleague, Stephanie Frisch, to talk about a small project that we've had on PFAS in consumer products, food service, and facility maintenance. To promote awareness and alternatives, and to let you know, some of the resources that we've developed, and also lessons learned, and some other challenges that we faced in this project, so that hopefully it can help you in your work. Stephanie, are you seeing the slides?
Yes.
Yes. Okay. So we've got a lot of people joining us today for the webinar. So when you have questions, please type them in. You have a GoToWebinar sort of control panel, and there should be a questions section there. So you can type them in at any point. We might not, Stephanie and I forgot to discuss this about breaking for questions. We might not do questions till the very end, but you can type them in at any point, please. Also, this presentation will get posted on the NUMOA website, and I will also send around an email to all the attendees once it is posted, and then where it is posted, you'll have access to all the other information as well. So we'll send that out to all the attendees probably sometime next week. So I think with that, we can just get going here. I'm going to turn my camera off. It'll make the slides a little bigger and it won't be so distracting. And we'll just get going. Great. So what is NUMOA? So NUMOA is the Northeast Waste Management Officials Association. We are a nonprofit, nonpartisan interstate association made up of the solid waste programs, the hazardous waste programs, the waste site cleanup programs, and the pollution prevention and toxics reduction programs in the 8 Northeast states, which are Connecticut, Maine, Massachusetts, New Hampshire, New Jersey, New York, Rhode Island, and Vermont. We were formally recognized by EPA as an interstate association in 1986. So, and then just general information about NUMOA is at NUMOA.org. So a little bit about the project. This was a USDA solid waste management grant, focused on, those grants focus on work in rural, low-income areas to protect water resources. And we had some partners on the project. We had the Northeast Kingdom Waste Management District, which is in Vermont. It's up here in the Northeast Kingdom, they call it, this sort of Northeast quadrant of Vermont. Also, Vermont Department of Environmental Conservation participated, the New Hampshire Department of Environmental Services, and then over in Maine, the Androscoggin Valley Council of Governments, which is sort of this sort of area along the New Hampshire border, sort of up in the middle here of Maine. That's sort of the Androscoggin Valley. So, and the project was aimed to educate the public about and businesses about the rising PFAS issue and how their actions could impact water resources. We also have a little disclaimer here that we should put on all of our materials, which is that, this is sort of presentation by Stephanie and I. We're not necessarily representing the USDA, any of our member states, or the project partners. This is a presentation that Stephanie and I put together. So the project was focused on consumer and commercial products and the impact of PFAS on waste streams. And the purposes were to educate the public, municipal officials, and businesses on PFAS in products, and encourage the purchase of PFAS-free alternatives, and promote practices that reduce environmental release of PFAS. And it was really not to provide information on what to do with products that you might already have that might contain PFAS. So PFAS in consumer products. So we produced 5 fact sheets for the public. So they were aimed at just the average citizen. And we'll talk more about those. We performed today is the last of 13 outreach events. So we did some farmer markets in Maine, New Hampshire, and Vermont last year. And then we've done a bunch of webinars recently, also one site visit to a nursing home that I'll talk about. And then we did a street fair in Vermont just last week. And then we did also develop a guide for food service. It's about 8 pages, so it's not real long. It's sort of high level, and but it's about, more specifically about food service. By food service, we mean regular restaurants, but also institutions that have cafeterias like hospitals, schools, nursing homes. Also, a lot of grocery stores have takeout food. Also, I'm trying to think of what else, but there's a bunch of different things that are in food service. So it's not just restaurants. So we'll start with a little bit of background on the chemistry and toxicity and why we have a problem. So just to give everybody a little bit of base knowledge, PFAS stands for per and polyfluoroalkyl substances. It's a group of thousands, literally, of synthetic chemicals that are used in hundreds of products. These compounds do impart very useful attributes, so that's why they're so widely used, because they help with water resistance and waterproofing. Also oil and grease resistant, that comes up in food service a lot. Also stain resistant, everybody likes their carpet and their clothes to be stain resistant, and it also reduces resistance to friction, so it helps make things more slippery and molds release and that sort of thing. And they are known as forever chemicals. I'll talk about that in a minute. And the main characteristic is that they are fluorines attached to carbons. So if we look at these structures over here, just give a tiny bit more background. So these middle things are considered carbons. These are chemical structures. Each carbon can have 4 attachments. And with PFAS, they're either attached to another carbon, so one of your connections is to another carbon, or they've got fluorine on them. And then there'll be like one compound at the end that's something else. And that can vary widely. That's why there's so many compounds. So this is considered a fully fluorinated compound because it just has one thing that's not a carbon or fluorine. And these are the 2 compounds that are most widely studied, that we know the most about, PFOA and PFAS. And they are known also, you might hear like C8. That's because there are 8 carbons on these compounds. So these are C8s, and they're fully fluorinated. You might hear C6, C4, C10, C9, C7, and that's just shorthand for the number of carbons. Now, these are fully fluorinated. Like I said, they have fluorines everywhere except the one attachment. There are also the polyfluoroalkyl substances, which might have these odd structures or other chemical structures in more places. So they might not be fully fluorinated. This compound might have, this other structure in 3 different spots. And so those compounds can actually sort of break apart until they are the fully fluorinated form. So polyfluoroalkyl substances are also what they might call precursors. You might hear that word too. They're a precursor until they break apart into only the fully fluorinated forms. Okay. So Another thing is just most people think that if something is for sale, you can buy it, it must mean it's safe. But that is not the way our system works, unfortunately, particularly for chemicals that have been out in commerce since, before we had a little more modern regulatory system, maybe in the 90s or the 2000s. So a lot of these chemicals, as you can see, a sort of a history of PFAS. They were sort of first invented by accident in 1938, used a lot during the war because they're so durable. And in the 50s, they started using Teflon in consumer products. We want our nonstick pans. In the 60s, they made the aqueous film forming foam. That's a firefighting foam for things that you can't put out with water. And then in the 70s, they used PFAS, was just significantly increased the use of PFAS because of all those great attributes that we like. So they started putting it in all kinds of places. And then it was about the 2000s when people started realizing there might be some problems and issues. So this slide gives a little history. So why are they so problematic? They are because that carbon-fluorine bond is just not natural. It's created with tremendous heat and pressure, and it's just not going to break apart. Unless there's tremendous heat and pressure applied to it again to break it apart. So in nature, it's just not going to break down. So like I mentioned before, the polyfluorinated compounds can break apart until they're just the fully fluorinated pieces remain. But basically these compounds are accumulating. They're just accumulating. We're still making them. We're still using them. They don't break down. They don't disappear. They're just accumulating. They're in all of our blood, and they're in the blood of all kinds of other creatures on the planet. So there's really, they're a problem. So they also impact the health, even at exposures of relatively low levels. And they have polluted our water supplies. So public water supplies must test for PFAS now, and about 17 of them in Vermont. And so again, this project was focused mostly in those areas, and about 30 water supplies. Now, public water supplies does not necessarily mean an entire town, but it could mean the water supply for a neighborhood or a community center, some sort of public facility, but approximately 30 in New Hampshire also exceed what the current standards in those states are. And then our private wells can also be contaminated from a variety of sources, including septic systems. And until recently, PFAS were just not regulated chemicals. Some PFAS structures, like the PFOA and the PFOS, are now have some regulations even at the federal level, and some states have, developed their own in absence of federal regulation. But, really the vast majority of these compounds are not currently regulated. So toxicity and health effects, these are some of the most well-known health effects. So reduced immune system function, this could impact vaccines and the efficacy of vaccines. Also just your general immune system, increased risk of preeclampsia in pregnant women, increasing cholesterol levels, decreased thyroid function, disorders and hormone disruption, and then increased risk of some types of cancer, including liver, kidney, prostate, and testicular in particular. So PFAS how PFAS in products might impact the environment. So like I mentioned, they really don't break down. They just kind of move around. So they can get into the groundwater and surface water used for drinking. And that's certainly the most significant exposure that people can have. If PFAS are in your drinking water, you're definitely having a much higher exposure to PFAS chemicals than someone that doesn't have PFAS in their drinking water. Oops. So this is very simplified diagram, but we're just trying to get across the point that things all move around. But if you have your PFAS containing product and then you're laundering it or you're bathing it or you're washing floors, that wastewater is going to either be going into a septic tank, which then is putting PFAS into the soil, and then from the soil, it's going into the water, and then that water could be used for drinking, or you might be sending it to a wastewater treatment plant, but then that wastewater treatment plant is not capable of, the regular process there does not do anything for PFAS. So I'm sorry, this cursor so it can, they're releasing some of it to the waterway that they discharge to, but also the treatment plant is probably developing biosolids or just sludge. And then the sludge is either, if it's biosolids, it's being applied to soil, and then it can get in the system that way. Or if it's just stays sludge and not really turned into biosolids, it's going to go to a landfill, but then that landfill is sending its leachate most likely to a wastewater treatment plant, which is why there's arrows on both ends of this line. So with that, I'll just say simplified. There's definitely nuances here, but there are definitely, it's important to note. So products and our use of products, and that is not the only way that PFAS get in the environment. So we know firefighting foam is a huge source of PFAS in the environment. The use of firefighting foam to put out fires, or for practice, or for routine maintenance that they have to do, requirements. Manufacturers that are making the different products that contain PFAS, they're potentially putting PFAS in the environment as well. And then we just have air deposition. There's PFAS just in the ambient air that's around us. So there's definitely other sources besides our use of products. But studies have shown that wastewater from homes and us, definitely has significant amounts of PFAS in it. And so we have a study that was done in Vermont in 2021. They worked with 2 communities to look at the residential, commercial, and industrial sources of PFAS into their wastewater treatment plants. And they found that much more mass of PFAS was originating from residential areas. So, you can look at the sewer lines coming from different parts of town, and there was a lot more PFAS in what was coming out of residential areas than what was coming out from their commercial or industrial discharges. And the industry, an industrial source is tending to use one sort of type of PFAS, and so you could sort of identify, oh yeah, this is coming from the industry, but they found that it really wasn't a significant source of the mass of PFAS that was going to the wastewater treatment plant. So all of us do have, are a part of the problem. So what products often contain PFAS? We've got, though, like I mentioned, the water resistant, waterproofing, the grease and grease resistance and grease proofing, and oil, stain resistance, stain proofing, stain releasing qualities, and then also this to make things sort of slick and to increase their durability. PFAS is also can be used. And so now I'm going to turn it over to my colleague Stephanie, who's going to talk to you about the fact sheets that we've generated.
Great, thank you, Jennifer. So as Jennifer was saying, as part of this project, we did some fact sheets as well as created a food service guide. So I'm going to walk us through that today. So this first fact sheet that we're looking at is really an overview fact sheet about why should I care, why should the public care about PFAS as an issue. And the key takeaways from this fact sheet is that there is exposure in our environment. It causes health effects to us, as well as there is environmental impact that leads back to not only ourselves, but the environment and the other species that are in the environment. So it's really important to understand just the general issues around the chemical in general. And then the other aspect that this fact sheet tackles is that really children can experience heightened exposure due to PFAS because of their hand-to-mouth ingestion, as well as close contact with PFAS-containing items such as carpets and rugs, which can lead to inhalation of PFAS-containing dusts, and also from eating those, putting things in their mouths. So that's one heightened concern with children. And as Jennifer said, this project really focused on what we can do. So the major takeaways from this fact sheet is generally checking labels, reading ingredients, and being aware of where PFAS are in our products, and understanding that they often are considered proprietary ingredients, so manufacturers often do not disclose their use in their products. So focusing on those key terms such as stain resistant, waterproof, oil resistant, and so on and so forth, as Jennifer was mentioning, is one of our key ways to determine if a product likely has PFAS. And the big question is, do you want to limit your PFAS exposure, and how to do so? The biggest thing is to reduce the number of PFAS containing products that we purchase and that we use in our day-to-day lives. Next slide. Perfect. Thank you, Jennifer. So the other fact sheets that we created were 4 product categories. The first one being clothing and other textiles, second, foodware and packaging, next, outdoor recreation, and then finally, personal care products. So I'll go into more depth on the following slides. And these fact sheets can all be found on our website. We have a resources page at the end of our presentation that will show as well. So the first big thing is, generally with PFAS, be skeptical about these PFAS-free claims that companies are making. A lot of companies state that their products are PFC-free, PFOA-free, PFOS-free, but these statements really cover specific chemicals rather than the whole class of PFAS. So they're likely still using different PFAS in their products. And even if a website states that they're PFAS-free, it doesn't always mean that it is. Like I said, these chemicals are considered proprietary ingredients, so they're often not disclosed, and the only way to really know what products have PFAS is analytical testing. A great example of this is that although a specific chemical was banned in cookware, PFOA, in 2014, a lot of non-stick pans, including Teflon, still continue to use PTFE, which is just another PFAS chemical. Going into clothing and textiles, our main takeaways from our research was that a lot of fabrics are treated with PFAS to achieve that durability, water, and stain resistant qualities that we all know and love. Some examples of textiles that could include PFAS include clothing, bedding, tablecloths, window or shower curtains, upholstered furniture, and rugs and carpeting. And the main concern with textiles and human exposure is really from that laundering that Jennifer was talking about in that diagram, how it gets into our drinking water, and then, as I mentioned with children, how these fabrics create dust in our environment that we inhale. So what can we do about clothing and textiles is, first of all, don't buy textiles that are labeled waterproof, water stain, oil resistant. Really look for these untreated natural fabrics such as cotton, linen, wool, hemp, and silk. Instead of choosing carpeting or rugs, choose a hardwood floor or a tile flooring instead. And if you are going to choose carpet, make sure to opt for carpet that don't have these resistant properties. And then if you do have carpet that you suspect could contain PFAS, generally just spot treating it with plain soap and water, then cleaning the full either clothing item or carpet or rug is a great way to reduce not only the amount of wastewater that is created from cleaning, but also reduce PFAS that are coming up off of that textile. And then one thing we wanted to note was, since PFAS wash out over time, we did find that continuing to use products that have been laundered for a long time rather than purchasing new is generally just as effective. Next is foodware and packaging in consumer products. So a lot of foodware and packaging are coated in PFAS to achieve especially oil and grease resistance. Some examples that include PFAS in this category include the nonstick cookware that I mentioned, paper plates and disposable tableware, coated food packaging such as bakery bags and pizza boxes, and then those takeaway containers. And the main reason for concern regarding foodware and packaging is direct consumption, your food being in contact with the packaging, and then you physically eating the food that has PFAS on it. And then also when you overheat cookware, vapors from the chemicals, the PFAS in it, can get into the air and you can breathe it in, as well as drinking water. Again, throwing these products out into our landfills or washing chemicals down the drain helps it get into our drinking water, which we obviously directly consume. So what can we do? We can choose cookware that is without a non-stick coating, such as stainless steel. We can choose to use reusable containers, and not only does this help the PFAS concern, but it also helps with reducing plastic and disposable items going into our landfill. And then if disposable is the only option, choosing those uncoated or wax-coated products that do not advertise oil, grease, or water resistant is the way to go. And then one other note that we have in regards to composting food waste is just please don't compost any containers or packaging that may contain PFAS. This not only helps it get back into the environment quicker, but it disrupts our adding chemicals into the compost, which is not good for when we use that as a soil amendment. And one note on this slide is that non-stick cookware, because it contains those PFAS, cannot be heated above a certain temperature, so we do recommend only using low to medium heat with those PFAS containing cookware items. And then another be skeptical messaging that we have is for green messaging. A lot of molded fibers and recycled paper disposable tableware are being recycled or being advertised, as compostable, but they are often treated with chemicals such as PFAS to achieve those, again, same terms, water and grease resistant properties. PFAS can be mixed into the paper pulp during manufacturing, so it may be present even if there isn't an obvious physical coating. So we do recommend just choosing to dispose of these in the trash rather than compost, and just be really careful about what you do choose to compost. Next is outdoor recreation. So our key takeaways from this category were that there are tons of PFAS in outdoor recreation. They're in bike lubricants, boots and shoes, their care products, rain gear, and other outdoor clothing. Tons of waxes, including ski and surfboard, boat and hockey waxes, tents, backpacks, anything with those waterproofing qualities, again, likely contain PFAS, including those waterproofing and protectant sprays. Again, our main concerns for human exposure come from direct consumption of the dust that come off these garments. Another concern is consuming game and fish from the environment, and then it getting into our drinking water, either from directly splashing off your raincoat and running into the stream that you're walking by, or from washing those products, as well as breathing in vapors when you're applying textile, protectant sprays, waxes, aerosols. All that can be direct consumption. So what can we do about outdoor recreation and the volume of PFAS in this realm is choose to use PFAS-free wax when you're using those products that need to have a coating of wax. One thing that we found is if you are able to flick your wax with a little bit of water, wax doesn't generally lead to beading of water particles, but PFAS does. So if you just flick a little water, say on the bottom of your ski, you probably, well, hopefully you won't see beading of water and then your wax is PFAS free. But if you do, it's a good note that your wax likely contains PFAS and to find an alternative wax to use. Other considerations are limiting the washing of durable water repellent DWR products. These are often rain jackets, rain pants, any of those true waterproof coatings. Try and spot clean with soap and water to minimize PFAS release rather than washing your garment or backpack or tent fully in a load in the washer. And then if you do have to use PFAS waterproofing products, we recommend a rub-on product rather than an aerosol product, just to reduce the amount that you will physically be breathing in. And then similar to these products, we recommend for using a PFAS-free boot and shoe care product, such as like a paraffin wax, rather than choosing one of these waterproofing products if you can. But again, if you are going to use those products, choose a rub-on. And then just a note about fish and game. PFAS can be found in fish and game, and we do recommend that you check local do not eat advisories before consuming any of these species. Many bodies of water, fish and game, have not yet been tested, so there's still a lot of unknown data that needs to be collected. Next slide, please. Oh, personal care products. Thank you, Jennifer. So key takeaways from this category are the long-lasting cosmetics are likely to contain PFAS, such as sunscreens, mascaras, anything that has that 24-hour rating to it. Some examples of personal care products that could contain PFAS includes cosmetic sunscreen, body lotion, dental floss, nail polish, hair care products, cleansers, and shaving cream. Really, the whole list of personal care products. So primary concerns with personal care products for human exposure include direct consumption by placing these products really close in and near the mouth and directly on the skin. And then when it is washed off our bodies, it goes directly into the wastewater, which can affect our drinking water. What can we do? We can choose sunscreens and cosmetics without PFAS. Again, that same messaging of just making sure to try and reduce our exposure to PFAS as much as possible, avoiding waterproof and water-resistant cosmetics when possible, choosing PFAS-free flosses such as uncoated natural fiber flosses or wax-coated flosses, and then also considering using pressurized water flossing to limit the exposure to PFAS in our mouths and reduce our single-use waste as well is a great way to avoid PFAS and floss. One note that we have about personal care products is that there are 2 PFAS formulations that are commonly found in sunscreens: PAP, polyfluoroalkyl phosphate esters, and PTFE, that polytetrafluoroethylene, that are also found in those nonstick pans. Really reading the ingredients list to see if there's any ingredients that say fluoro in it. Again, analytical testing is the best way to determine what products do and don't contain PFAS due to the lack of labeling. So next is our food service guide that I'm going to talk about. There's a lot of continuation of the same themes and same aspects of what we can do for these food service exposures. So this is our guide for PFAS and food service, promoting alternatives. This can also be found on our website and is linked in the resources slide at the end of the slideshow. So our first diagram is our potential exposures for food service. Again, similar ideas as the foodware and packaging, consumer products fact sheet, focusing on direct consumption of our water, vapors from our heating nonstick pans, takeout containers and food containers. And then a couple new ones are our carpet dust and cleaning chemicals, especially stripping, floor stripping and waxing. And then again, similar to the textiles is our stain resistant, but this time uniforms, tablecloths, and napkins. So we really want to emphasize that understanding which products likely contain PFAS helps us avoid not only purchasing them, but also reducing worker and consumer exposure, which again can decrease not only the amount of PFAS in the environment, but our exposure. So really important topics. And then from those items is the potential contamination that occurs from food service. So first being carpet cleaning, the wastewater from carpet cleaning, the chemicals itself and the carpet can contain PFAS, which can be either the wastewater can go down the drain or it can go out the back door. That is to note that that should be alerted to your state government if that's occurring, but we do want to recognize that it is a realistic possibility that it could be going out the door. So that's why we noted it in our diagram. Similar with floor stripping and waxing, it's really from the chemicals that are used in the stripping and waxing, so that wastewater can go down the drain, which can lead to contamination of the environment or out the back door. And then some other areas for specifically wastewater include washing those stain-resistant textiles such as uniforms, tablecloths, and napkins. Washing them can lead to that exposure in the wastewater, since the wastewater facility, as Jennifer mentioned, can't really treat those PFAS. They just go through the system. And then finally, our main other potential contamination is from food packaging and other things that get into our trash or into our compost that lead to direct exposure. So the wastewater and trash that contain PFAS can lead to the environmental contamination as explained by this diagram, which impacts the water resources. And again, choosing PFAS-free, not only items, but cleaning methods is a great way to reduce our exposure and contamination of the environment. So very similar to the last past slide that I had of food packaging and cookware, there's a lot of disposable dinnerware items that are used in food service that do contain these resistant, these chemicals, and that PFAS can transfer from packaging and cookware directly to our food is our biggest message from this slide. And that higher temperatures and longer durations of time that food is exposed to these chemicals can lead to greater amounts of PFAS directly into our food. One study that we wanted to highlight was the Washington Department of Ecology Food Packaging Alternatives Assessment. So this was in May of 2021, and it looked at viable alternatives that meet Washington's strict human health and environmental impact safety criteria. Some that met the technical performance of PFAS that are commercially available at a similar cost, making sure that there isn't a huge barrier to using these products, included wax-coated wraps and liners, kaolin clay-coated and reusable plates, reusable bowls, PLA plastics, and uncoated paper pizza boxes. So really focusing on hopefully those reusable items is a great way to not only reduce our PFAS use, but plastics use. And then when necessary, there are wax coated and PLA options that don't contain PFAS. So that was a great study to understand the realistic alternatives that are on the market. So what can we do about foodware and packaging? There is a list that's been compiled by the Center for Environmental Health that has no low F, no low fluorine products listed on a tab. It is a Google spreadsheet that demonstrates what products have been analytically tested, the date they were tested, and they do have some that were tested in 2021, so that is still relatively recent data. So that's a great resource to use. We also recommend looking for green screen certified products and BPI certified compostable products. Again, these go through a certification process, so they should hopefully have less to no PFAS in them, or at least determine what chemicals are in them. And then if you're not using BPI certified products, we recommend, again, that you only compost the food waste just to reduce contamination of compost. And then, as I've said before, choose reusable containers, use non-stick free cookware. And if you are using that non-stick cookware, choose only to use low to medium heat to reduce the amount of chemicals that make their way into your food. So when disposable is the only realistic option, similar to what was discussed in the Washington Ecology Study, we recommend choosing wax-coated or truly uncoated products, choosing products that have no advertisement of those key terms, oil, grease, water-resistant claims, and then avoiding disposable products whenever possible that have already tested positive for PFAS, such as those molded fiber products and molded recyclable paper products. And then again, similar to the cosmetics, if you see that there is a ingredient containing the word floral, that likely that likely denotes that there is some source of fluorine in the packaging, which could be PFAS. So PFAS in textiles and exposure, again, very similar to the consumer products, like I said. It still rings true for uniforms, tablecloths, napkins, upholstered chairs, booths, all these types of furniture that are often in food service environments. And it still is true that they enter the environment mainly through washing the textiles and disposing of these products in the landfill. And again, we're mainly worried about these products for their impact of drinking water and also breathing in and consuming the dust from these treated fabrics. We do want to note that with these fabrics, the potential for human health from wearing PFAS containing clothing while sweating and in hot conditions, which is often common in food service kitchens, is still unclear and future research is required. So that is something that we are watching. So what can we do about these textiles and food service? Again, choosing wood furniture, similar to wood flooring, as said before, with cushions that hopefully are from natural fabrics such as cotton, hemp, or linen, rather than upholstered furniture that's not only difficult to clean but often treated with chemicals. We also recommend purchasing textiles that do not have any labels of water, stain, or oil resistant. And when possible, again, choosing untreated natural fabrics rather than synthetic materials. Not only is it better for breathability of the garment, but also that the synthetic materials do contribute to other human health and environmental concerns such as microplastics. So hitting two issues here with that recommendation, and then considering replacing suspected textiles with untreated alternatives when possible can also reduce exposure. And now I'm going to turn it back to my colleague, Jennifer.
Okay, so I have to unmute myself here. Great. So thank you, Stephanie, for all that great information. Now I'm going to talk a little bit more about PFAS in sort of facility maintenance. So this would be for food service, but also as we'll talk about, lots of other applications where people, office buildings, big box stores, carpets, have lots of carpet too. So, and we, most people, when you buy carpet, yeah, stain resistant. Oh, that would be a great thing to have, right? So a lot of carpets, maybe they don't even, it's not, sometimes it's an after treatment, but also they could just be made that way because they're imparting this great attribute of stain resistance. So there's multiple pathways that can lead to PFAS entering the environment. So you're washing carpets, that they're picking up PFAS. The PFAS doesn't just stay exactly where it is all the time. Little bits flake off. It's going, so it's going to be in the wash water from carpet cleaning, and hopefully you're not putting it, just emptying the bucket out the back door. I just want to note that's a practice that's most likely illegal in most states. But if you have been doing that, you're putting the PFAS directly into the soil, which is, then leaching into the groundwater. But even if it's going down the drain, as we talked about before, it's either going to the septic system or a wastewater treatment plant, and that's still, ending up in the environment. And then carpet disposed in a landfill. Vermont did a study several years ago now looking at inputs of PFAS to their landfill, and they found that clothing like textiles and then carpets were likely a major source of the PFAS that they were finding in the leachate from the landfill. The textiles and carpets are a big factor in what PFAS is going into a landfill. So human exposure, again, drinking water that's impacted by getting rid of the wastewater, and then also the issue about breathing in and consuming dust from the treated carpets and rugs. So what you can do, food service wise, consider wood or tile flooring instead of carpeting. If you do put down new carpeting, try to find some that doesn't have the water, stain, or oil resistant properties. Probably, not ideal. So you got to look at the color schemes to try to one that would hide stains if possible. So you also want to frequently vacuum carpet with a HEPA filter so that you're not you're collecting the dust and it's not more available. And you also, again, want to try to spot clean rather than wash the whole thing if you can. And then, you want to try to make sure that the carpet cleaning products that you're using don't contain PFAS. So again, you want to look and just see if fluoro is listed, some compound containing that word there is not listed. But really the only way to know for sure, because a lot of these materials, these compounds are considered proprietary, or they're used at amounts that don't require them to be labeled, even though they could still be a problem at those amounts. So, testing is really the only way to really know. But you really never, ever want to dispose of your wash water from carpet cleaning out the back door. And if you're on a septic system, you should really try, if possible, to collect and dispose of that wash water with a hazardous waste hauler or bringing it to a wastewater treatment plant. And that's really not the most ideal. So, again, the best way to ensure that you're not releasing PFAS to the environment and having exposure is to just not have PFAS containing carpet. So I also do have some slides. I'm sorry, I didn't get everything together in time. If people want to bear with me towards the end, I can pull up some other slides from someone else to show some test results, because the New Hampshire Department of Environmental Services did do some testing of some carpet cleaning products and also the wash water from carpet cleaning. And I could show you the types and levels of PFAS that they found. But it is a legitimate concern. There's definitely PFAS. Not in all carpet cleaning products. Some of them don't have it, but some of them do have it at pretty high levels. And then also the wash water, uniformly, everything that they tested, the wash water from carpet cleaning did have PFAS in it. And likewise, floor stripping and waxing. So again, there's multiple pathways that might lead to PFAS entering the environment, similar to the carpet cleaning. Definitely, just disposing of that wash water, emptying that bucket out the back door, that's most likely illegal where you live, but also it's a direct discharge of PFAS to soil. Wastewater disposed down the drain, again, it's the same problem with septic systems or the wastewater treatment plant. And a little bit different with the floor stripping and waxing. So you definitely have the drinking water impact, but also the levels in floor stripping and waxing products are at levels that might be concerning for worker exposure. There might be, indoor air impacts that are of concern. So again, New Hampshire Department of Environmental Services did a study. They looked at 4 schools. This is a report that is available. I believe we have a link to it on the NMOA website in our resources section, but also you could just Google it. It was just published this year. They chose 4 schools that are on septic systems. So we're in rural areas, they're on septic, and they also have their own drinking water wells. And that drinking water was impacted by PFAS. So they found high levels in the wastewater from floor stripping at all 4 schools. They found lower but significant levels in the wastewater just from routine floor cleaning, so not the stripping. And the floor stripping and the finish, the wax products, they tested what those 4 schools were using and found very high levels of PFAS. So carpet cleaning is a problem. Floor stripping and waxing is like an order of magnitude greater problem with PFAS. And again, I can show slides. I just don't have them incorporated here. If people want to bear with me in the end, I can show that. But I will say all 4 schools were using different products. So it's not like they were all using the same product. Everybody was using different products, and all the products had PFAS. And they really think that the disposal of this wastewater from floor stripping and finishing is what has contributed to the contamination of groundwater that the schools use for the drinking water. And then when you think about, it's not just schools that are doing the floor cleaning and stripping and waxing, you know, it's big box stores, it's supermarkets, it's hospitals, it's nursing homes, it's municipal buildings. I mean, there's a lot being used, and then the wastewater disposal. So what you can do, you want to avoid floor cleaning as much as possible and dry sweep if you can. I think someone raised the issue that there might be asbestos in some floor tiles though, so you don't want to be dry sweeping. That, which could be another issue, if you know that your floors have asbestos, then you probably don't want to do this. To the extent feasible, you want to clean the floors with plain water. You want to try to ensure that your stripping, finishing, and cleaning products do not contain PFAS. So again, you want to look for that key fluoro part of an ingredient. And then also really the only way to know is to test. I will talk a little bit more about that because we are actually doing a little bit of testing here. And then you just never want to dispose of it just, you know, out the back door. Like I said, that's probably illegal as well. If you're on a septic system, particularly if there's drinking water wells, you want to try to collect and dispose of it properly. Although that's, you know, a challenge that is difficult to actually make feasible. Oops. So we did visit a nursing home. It was envisioned in the beginning of the project that we would be visiting a school, but it didn't turn out that way. But we went to a nursing home just recently. It's a good sized nursing home. It has 4 different resident neighborhoods, so 4 different, so on 2 levels, and each level has 2 wings to it. So they're sort of self-contained. They each have their own cafeteria, dining hall area. And when we were there, we looked at food service, that their food preparation. Generally, they don't use nonstick cookware. It was all stainless steel, so that was good. They don't really use disposables, very rarely. Like if the dishwasher was broken, they said they might use disposables, but we tried to look at what they do use, and they really don't use disposables, which is also good. And we looked at the uniforms and aprons that they purchase, and they're not advertising stain resistant. They look like they're made from cotton. So in general, from food service, we had a low concern for PFAS. But there is a little bit of concern. I did visit with someone from New Hampshire Department of Environmental Services who did those other studies on the floor waxing and the carpet cleaning. And she was wondering, well, they use a rinse in the dishwasher. And what's the rinse for? Well, to make the glassware shiny and slippery, for the water to run off. Could there be PFAS there? We're not sure. Then general operations and cleaning, we assessed that. Generally, they're using off-the-shelf products like Spick and Span and Mr. Clean for their general cleaning. of the facility. The bedding, on the residents' beds is just sheets and things, or a cotton poly blend. And then they really aren't using mattress protectors, mattress pads. They use some smaller pads because I think residents have accidents maybe more regularly there. So, and they use the smaller pads as well to put on chairs where people might sit. And those are a polyethylene laminate with a, cotton facing. And generally, we had a low concern for PFAS from the general operations and cleaning, although, maybe the laundry detergent, that could be something to look at. But then we looked at the floor cleaning, stripping and waxing. They've got the hallways, the dining rooms, the resident rooms, they're all just floor with some area rugs, but basically it's all floor. And the cleaning staff uses a floor restorer weekly. So it's to keep things looking good, but not a full stripping and waxing. They probably just do that full stripping and waxing, two times a year, 3 maybe. But they did express like, hey, we can't just dry sweep, we have to look clean for the inspectors that might come, but also for the residents or potential residents and the family members that are visiting. You can't, they really thought you have to have the floors looking good. So the dry sweeping idea was just not seemed realistic. But we did take some samples of the products that they're using, which again were different products than the 4 schools. And we took samples of the floor stripper, the wax, and then the restorer product, the one they're using kind of weekly. And those have been sent for analytical testing. Unfortunately, the sample collection was only recently, so we don't have the results to mention right now. But most likely there's PFAS. But we also are testing 2 products off of EPA's safer choice list, because as we've mentioned before, it's really challenging to know for sure and to be able to recommend, because of course we're saying, oh, PFAS is in the floor stripping and waxing products, and people are like, well, what can we use instead? And we really can't say what is appropriate. So we're just double checking these floor finish and a floor wax that are on EPA safer choice. There's a couple of them, or 3 maybe, different products that are listed there. Some of them were not available to purchase in a quantity that was realistic, but we are testing a floor finish and a floor wax. So again, those results, I can share them with everybody that's on this webinar later when we get them, which will be in another month or 2. So, but hopefully we'll be able to say, yes, you can actually recommend these products because they came back with low or no fluorine in them. And let's see. So the bottom line is the best way to prevent releases to the environment and protect water supplies and human health is to just stop using these materials. But manufacturers don't often know or disclose that their items do contain PFAS. So I think a lot of manufacturers, don't know for sure, or they're a distributor, it's manufactured overseas and they're importing it, and they don't really know. So the only way to really know is to conduct analytical testing, which is expensive. Although just to test for whether it's got fluorine in it is not that expensive compared to trying to figure out exactly which PFAS chemicals are in something. So just to a screening test is like, does it have fluorine in it or not? And if it doesn't have fluorine in it, then it doesn't have PFAS. So some key lessons and takeaways from the project. We'll do those. So the project challenges. We did have limited engagement with our project partners over time. The first year was good, but then into the second year, there was some shifts in some state staff got moved to different positions, and nobody was really put in their place. One of the local partners, the folks in Maine, they lost some funding, so they didn't have a person that could participate. And then we had just this summer some really severe flooding in the Northeast Kingdom area. In Vermont, they had 2 major flood events in July. And so that sort of took them offline as we were trying to get a few of these project end things done. Generally, PFAS is a really complex issue. So the written materials, the fact sheets that Stephanie showed you, they've got a lot of text on them, and that's really not ideal for things that you want people to be able to quickly sort of consume. But it was really challenging to even get them to fit on, front and back of one piece of paper. And then at outreach events, it was difficult to engage people that didn't have any prior exposure to the PFAS issue. Personally, I thought PFAS has been in the news so much that, everybody would know about it and they would know, but, a lot of the people that we encountered at all the outreach events that we did really didn't know about PFAS. So it's much easier to answer people's questions than it is to try to say, hey, look at this issue. We also had challenges with advertising the outreach webinars. It was really difficult to find contacts for local businesses. Like, we might have a list of the local businesses, but finding email addresses we didn't have the capability of mailing postcards or doing something hard copy. So, trying to find how you would email people was challenging. And then we also had an issue with the local partner, the one that we did have remaining for these webinars, really had limited capacity to do some emailing. They just were busy with other things, and they had the flooding. And so they weren't really able to send emails. I think they did send one set out from them. So, the bulk of the advertising of the webinars was done just by Stephanie and I. And, people just really, I'm missing an N there. NMOA is not a known with an N entity. People don't really know what NMOA is. So getting an email from myself or Stephanie, they're probably not likely to open it even. So that was definitely a challenge. So, that meant that the outreach webinars didn't have a large participation. And then, the one-on-one school visits that we envisioned were difficult to arrange. Again, we had limited capacity from the local partners. Fortunately, no schools in that Northeast Kingdom of Vermont area had PFAS exceedances, so they weren't really that invested in trying to have somebody come and help them. So at the last minute, we were fortunate to be able to pivot to the nursing home. That was mainly because I had worked with them on a different project a few years ago. So there's some challenges. Let's see here. Some more general challenges, just that few of the PFAS chemicals are regulated and the health impacts of most PFAS are unknown. So, again, the messaging is difficult. Like we just talked about, PFAS-free claims, really can't be trusted without testing. And so that really, everybody wants to know, well, what can we use instead? And we can't confidently provide alternatives. Now, I will note that some states are passing legislation, recently, some states have passed that are going to require manufacturers to report on PFAS. So we should have more information, better analytical knowledge in the future, but it's not necessarily now. Most of the testing information that is out there, studies that have been published, and other resources, a lot of that is from 2017, 2018. So it might be outdated, particularly about things that do contain PFAS, because, what was true 5 or 7 years ago, there is more awareness about PFAS, and so manufacturers are trying to move away. So things that tested positive a while ago might not necessarily be true today, but because of the lack of analytical testing and transparency, we really can't even determine the validity of what I just said. And some huge challenging questions remain, particularly, if you already own PFAS containing items, what should you do with them? If you have carpet in your house, if you have upholstered furniture, like that sunbrella stuff, or I know I went into a store and they had all the tablecloths and Teflon, it's Teflon coated. But if you have those already, what should you do with them? That's still, landfills don't want them. Household hazardous waste doesn't want them. We don't want people to just empty their conditioner bottles down the drain. So, what's the answer there? Couple more lessons learned, and then we're almost done here. So we did learn some of the outreach events were at farmer markets, which were great because people are there with their families. Street fairs, other county fairs, those sort of things. Social events are better for engagement. Then we did do one outreach event at the recycling center, and people really are there. They come. A lot of times it's just one person because it's an errand they're trying to get done. They really want to move on to other things. And it really was difficult to engage people at a transfer station or recycling center. So some of the more community social events would be better. Also, you need to be prepared to encounter, hopefully small number of people who believe that the whole issue is fake. Fake media and PFAS is not a concern. So just to be prepared that might happen, maybe talk about what you could say to those folks, or just to, not be offended or thrown off balance if that happens. And then we also were envisioning originally in the project that we would do in-person workshops, but that really turned out to not be feasible because we really needed the local partner to arrange that and invite people, but they had limited capacity. In the Northeast Kingdom Waste Management District, that's a municipal association of the municipalities up there. Quite a few of them, I think there's over 40 or around 40, but their board meetings now are just occurring virtually. They used to meet in person, and in prior projects, I could come up and present to them, but now that was, they're being held virtually, and we did present to them, but it was, not an in-person workshop. And then also, like we mentioned before, we were originally going to be targeting community members, the government and municipal officials, but, overall there was just less community knowledge and interest in PFAS than we had anticipated. We just thought, it was just more widely known than I guess it really is, because we were always working on it here at work, but not everybody else is. So we did have a few successes. We did do in-depth research of PFAS in consumer products. We did have good project partner engagement the first year, and that was very productive. We published those 5 fact sheets and the food service guide. The references, you can get to them on namoa.org, but we also have more direct link at the end of the presentation. So the research, this is kind of what it looks like. This is a sort of a screenshot from the NAMOA website. So there's the different fact sheets, and then we just expanded the one for outdoor recreation. So you can see what is under there, and the different information that you can find. So there's a lot of background information on the NOAA website as well. And we were able to do that one in-person visit to the nursing home, and we are doing real analytical testing in partnership with New Hampshire DES. A little bit more success, and a terrible picture of me as I'm getting older here. But we did lots of outreach engagement. We increased community awareness in a lot of communities. We interacted with over 97, these are more exact numbers, 97 people at New Hampshire farmer markets, 168 in Maine. Because we happened to coincide with some really good community events that were happening at the same time as the farmer market. In Vermont, because we were at the recycling center as well, we just didn't have as much engagement there. And then we just did that street fair and interacted with almost 70 people. And we've been doing these webinars this summer. This particular webinar, we're not doing a before and after survey, but we did them for the other webinars, and they all showed that the majority of participants learned more about the issue and that they do plan to explore the alternatives that they learned about. So with that, that's sort of the end of the formal presentation. We do want to just say, if you know of more recent analytical data on PFAS in products, or that you have some additional practical solutions beyond the sort of what you can do that we presented on, please email us, please let us know, please type it in the questions. And let's see. I forgot to make Stephanie an organizer, so I guess I'm the only one that can look at the questions. You can see them?
Mm-hmm.
Oh, okay, great. Are there any good ones that we should?
Well, first I want to note that a participant did share that the FDA announced that PFAS used in grease-proofing agents for food packaging is no longer going to be sold as of February 28th, 2024. And that it could take up to 18 months for the market supply to work through the final PFAS containing grease agents, but that is an update for food packaging. So thank you so much for sharing that. And then just going through the questions here, how can a consumer find out if a product has PFAS, especially looking at popcorn bags? Again, focusing on those main labels that we've been talking about during this presentation. They likely won't note that a popcorn bag has PFAS in it, which potentially after this market cycle, according to the FDA, maybe they won't have PFAS in it due to the grease coating being removed. But also a great way to reduce that exposure is just choosing to buy popcorn kernels and pop them in a pan or in one of those silicone poppers in the microwave could be a good way to reduce our exposure through popcorn bags. And then another question is, are there any labeling requirements for PFAS in consumer products? Especially interested in the compostable products segment. Jennifer, do you want to take that one?
Actually, I'm trying to pull up the slides from the other presentation that show the analytical results. I haven't. Sorry.
My understanding is that no, there aren't any labeling requirements for PFAS in consumer products, especially since the PFAS are often proprietary ingredients. I'm not sure if anything is changing now that EPA is regulating A few of those PFAS chemicals, those might require either reporting or labeling, but I don't have the most up-to-date information on that. So we can get back to you on that question. And then thank you for another question. Yes, these slides will be posted to our website after this presentation along with the recording. And then what happens to PFAS that are sent for disposal at a waste combustor? I'm going to have to wait for Jennifer to weigh in on that, as that she's more the expert in solid waste and waste site cleanup.
Well,
So,
I'm back now because I did
oh,
pull up the
great.
slides, which I can also show in a minute. But so that's a good question. So there are concerns because everybody also wants to be able to destroy these compounds and material that contains them. And what can we do? So, they're not sure at this point about incineration completely destroying the PFAS, breaking apart those bonds so that they just are becoming carbon and fluorine and they're not a harmful compound anymore. So there's definitely concerns, and a lot of people, it's sometimes it's better not to test so that you don't know. So, I mean, EPA is trying to really study this because so many people want to know if we can send, the AFFF, the firefighting foam, can we send it to a hazardous waste incinerator, and will it be destroyed? Or will it come out, end up in the air pollution control system, waste, or be emitted to the atmosphere? So the whole thing about incinerating material, and then, I don't know if anybody's looking too much at municipal waste to energy facilities, our trash waste to energy at this point, because what are we going to do? Like, there's nothing that, we don't have solutions at this point, unfortunately. Hence the need to just stop making and buying these products so that they're not ending up in our trash. It could go, yeah. Sorry, there's not a better answer.
Great, thank you, Jennifer. And then another participant asked if there will be a link or copy of the report for the New Hampshire DES study of the 4 schools available. We'll make that available on the event page where the slides and the recording of this webinar will be posted, so that will be easily accessible from our website as well. And then another question is, are there any recommendations for household hazardous waste acceptance programs and how they can approach this problem?
Yeah, it's the same thing. There's no clear thing to do with these materials. So, in general, nobody's encouraging people to bring them to household hazardous waste. Just put them in the regular trash at this point. Yeah, there's not. So I do have those slides up that I can show for the carpet cleaning and the floor waxing and stripping. So maybe I'll do that before too many other folks drop off. Should I do that? Do people want to see that? And then we can do questions afterwards again. More questions? Okay. So these are slides that were graciously provided by New Hampshire DES, and this is their carpet cleaning, PFAS and carpet cleaning. They sampled 4 cleaning businesses. They looked at the cleaning products and then also the wastewater, and they analyzed for 70 PFAS compounds. And here's the results of the concentration in nanograms per liter. She does have a little arrow, the groundwater standard which is for drinking water. In New Hampshire is way down here. And this is the wastewater. Oh, actually, look, there is one. Site 4 doesn't really have much. But the other ones had quite a bit of PFAS in the wastewater. Now, you know, the volume is maybe not that huge, but it depends on how often you're doing this. I guess if it's a business, you're probably generating a pretty good volume. And then here's the cleaning products that they tested. So this is the wastewater, which could be also having PFAS coming out of the carpet. But then here's the cleaning products, the soap or the stain spot treaters that they're using. I don't really know what all these abbreviations stand for, but that is sort of the results from that. So showing that it is an issue. I mean, this particular product is, they had to break the scale here and go all the way up to almost 1 million, almost 1 million nanograms per liter. And then here, so keep in mind where we're at here. So most of the wastewater is down here at like maybe 120, 130 nanograms per liter for carpet cleaning. Here's the floor stripping and waxing. Again, they went to 4 schools. They looked at the strippers and the finishes and the wastewater and analyzed for the 70. So again, here's what's in the wastewater. All 4 schools. And then they tested the stripper. Here's a couple that didn't have it. Okay, that's good. And the floor finish. This is the wax. And these color codes, it doesn't show here, but are related to certain compounds. So that's just, I'll add these slides to the slides that we presented for the version that we will PDF and post on the website. And I will send a link to that when it's done to everybody that's on the webinar today. So with that, let me see. I guess I'm going to stop showing my screen. It's going to stick on this slide, but I'll do this one. Okay. Are there more questions, more thoughts as we wrap up here?
So the next question is, which countries manufacture PFAS, or do any specifically not? I personally don't know that answer. Do you, Jennifer?
Not necessarily. I think there's still PFAS manufacturing in this country because, like we said, there's not, all the different compounds are not regulated. The PFOA and the PFAS, those C8 compounds, I forget what year they were phased out voluntarily. It was sometime in the 2000-ish, I don't know, the mid to early 2000s, but I think those same compounds, the PFOA and the PFAS, are probably still being manufactured. You know, and a lot of our, you know, your rain jackets and all those things are being probably imported from China. So I'm pretty sure, you know, China and India are big. You know, I know there was big awareness. There's a lot of awareness in Europe now. So, you know, again, I'm not sure about all the manufacturing. You know, I know there was a huge manufacturer in Italy that caused a lot of widespread contamination there. I don't know if that company is still manufacturing in Italy or not, but certainly I would think China and India for sure, but there's, like I said, PFAS is still being manufactured here, just not those particular regulated ones.
Great, thank you. And then the next question is, for packaging with PFAS, when heated and PFAS is vaporized, have there been studies about the amount of PFAS vapor that becomes entrained in the actual food itself. I can answer this one. I'm sure there are studies that have determined how many PFAS are vaporized. PFAS can also enter the food that is directly cooked on a scratched surface, so it doesn't have to necessarily vaporize in order to enter the food. The food could just be in direct contact with the chemicals that are on that surface. Do you have anything more to add to that question, Jennifer? I know that there's a lot of resources out there, and the resources that we directly used are available on our website and in the resources section at the end of our presentation is the direct link.
Yeah, I don't have anything more to add. I don't know for sure.
Great. And then our next question is, would sunscreen have that PAP or PTFE in the ingredient list, which may make it less possible to identify with the fluoro spelled out in the ingredient name? From the study that we reviewed for those specific chemicals, they did some testing to determine those chemicals. I can't answer specifically if they were in the ingredient list on the sunscreen. For my personal use in looking at sunscreen ingredient lists, I personally have not seen where PFAS are listed in the sunscreen, just that say it lasts for an hour or two before reapplication is necessary, or that it's water resistant. So I would say that probably not going to be listed in the ingredients as those specific chemicals, since they're proprietary, probably not listed in the chemical ingredient list at all, but still something to note is that also if they're not only in addition to fluoro, but if there's an acronym that starts with a P, it's always good to look up those acronyms when purchasing products because it could easily be a PFAS.
Yeah, I will just add, in general, I don't know if this is specific to cosmetics as well, but a lot of times, like with the chemicals that you might use in a business, if it's at 1% or less, then it doesn't have to be listed. But 1% of something that if it's a PFAS chemical is a lot. So yeah, I don't know all the laws about what has to be on a label and not on a label, but in general, I know like those material safety data sheets, if something is in the product at less than 1%, it doesn't have to be listed. So I think they're trying to change some of that for the PFAS because they know the levels are lower. I don't know where the status of all the different regulations are, but
And then our next question is, where we acknowledge PFAS in carpeting and clothing. Do we know of any studies on exposure and contamination during carpet and garment recycling?
no, I don't know anything there. Yeah, that's actually a new area to think about for me.
Yeah, what I would add is a lot of our research was done during the winter of 2022-2023. So the most recent studies that have come out on this information, we are not as up to date as we were a year ago. And this is a continuing field that is quickly evolving and continuing to have great research done in different areas of the field. So continuing to learn about these, say the FDA announcement or things like that, is really important when asking these questions and answering them. So there may be a study out there that we are not aware of at this time that has come out more recently, but that is something that we are, as Jennifer said, is new to us and we're continuing to learn ourselves. And then
We got 1 more minute.
Yes. A lot of the questions have to do with more research studies, such as the safety of using BPI, foodware and products in compost. We are wary about that just due to the need for analytical testing to confirm that PFAS are not in products. And about the use of PFAS in food products or just food product containers, that's a great question. I mean, again, we're really focusing on the labels that are associated with PFAS. So hard to answer all these questions about studies that are out there, but we're continuing to learn, as I said, and excited at the progress that's being made.
Yeah, so I'll just show, this is the Center for Environmental Health, and the link is in the presentation itself, but it does, so this is food service. They were testing a lot of food service products, and they did do real analytical testing, and there's a tab here. It's a spreadsheet when you open it up, and there's a tab that says no and low F. And so it does have, you know, all the name brands and what the products, type of products are. And these are all things that that were tested and did not have PFAS, you know, any fluorine in them. So that means there's no PFAS back in when they were tested. So some of them are 2018, but it does go all the way. See, sorry, I went too far. Some of these things are from 2021. So this is a resource that you could be confident in, I think, because they did real analytical testing, and this is food service items. So.
Great, thank you so much.
All right, well, we are at 3:31 according to my clock here. So I think unless there's a real big, good question that we really should talk about, we probably should go. What do you think, Stephanie?
I think we've answered a lot of the questions that we can answer. The last one I see is what to do with nonstick pans or other questions regarding products containing PFAS. As we mentioned at the beginning of this presentation, we were really focused on reducing our use of PFAS from the consumer side rather than what to do post-use. So unfortunately, we probably don't have the best information for what to do with nonstick pans. As Jennifer said, no household hazardous waste or landfill really wants them, but hopefully continuing to start to take them out of our use and focus on other alternatives is the best we can do, but that's not an answer for the waste stream necessarily.
I think the bottom line is there is no good answer at this point. So everybody's working towards it, but we're not there. All right, great. Well, thank you, everybody, especially the 126 people that are still here with us at this late time. So thank you for hanging in there. I hope you found this useful. Like I said, at some point next week, probably you'll get an email with where the presentation is posted, and you'll be able to access it. But feel free to go on the NMOA website and find the information at this point. Okay, with that, I'm going to thank my colleague Stephanie and end the webinar, and hope everybody enjoys the rest of their day. Bye-bye.